Hey, welcome back. So I've got some nice exponential questions that I'd like you to solve without using a calculator. So let's go through this. So I've got 3 to the power of x plus 1 equals to 81. So how are we going to solve this without using logs, without using a calculator? Well, the key is to make both these numbers the same. We want the bases to be the same because once the bases are the same, you can make the indices, the exponents, equal one another. So we can make these, this is 3, and we can make 81 3 to the power of something. So let's write out all the powers of 3. So let's just make some room. So 3 to the power of 1, for instance, is just 3. 3 to the power of 2 is 3 times 3, which is 9. 3 cubed, 3 times 3 times 3, which is 27. 3 to the power of 4, so that's 3 times 3 times 3 times 3, that's 81. So bingo, we could use that. So instead of writing 81, we could write that as 3 to the power of 4, because that's what 81 is. So let's do that. So this equation, let's make some room. We'll move this over here. We still have 3 to the power of x plus 1 on the left-hand side, and instead of writing 81, I'm going to write 3 to the power of 4. Beautiful. And now the bases are exactly the same, so we could just say that the indices must equal each other. So x plus 1 has to equal to 4, and then you can bring that 1 across. So x equals 4 take 1, which is 3. So our first answer should be x equals to 3. Nice, nice and easy. Okay, let's try another one. So slightly more difficult. I've got 2 to the power of x equals 1 over 32. So let's do the same thing. So let's write out all the indices of 2. So 2 to the power of 1 is just 2. 2 squared is 2 times 2, which is 4. 2 cubed, which is 2 times 2 times 2, which is 8. 2 to the power of 4 is going to be 2 times 2 times 2 times 2, which is 16. 2 to the power of 5. So that's going to be 2 times 2 times 2 times 2 times 2, which is my 32. You could probably just, it's probably easier just multiplying those values by 2. So that's the one I'm going to use because we've got 32 here, and I can replace that with 2 to the power of 5. Okay, so we have 2 to the power of x on this side, and then we have 1 on, and instead of writing 32, I could replace that with 2 to the power of 5. Okay, so an indice rule that you need to remember, if you've got 1 over, say, x to the power of n, you could bring that to the numerator, but the indice becomes negative. So that's one of the rules that you need to remember. So we could apply that rule to this part. So my left-hand side still is 2 to the power of x. My right-hand side, you're bringing the 2 up, and the indice will become negative. Now, because the bases are the same, you can make the indices equal one another. So in this case, x just equals to a neg 5. So hopefully it's making sense. It's nice and fun. Let's do one more. So even more challenging. I've got 5 to the power of 2x minus 1 equals 125. Actually, this is not that challenging at all. You should be able to do this now. So step 1, let us write out all the powers of 5. 5 to the power of 1 is 5. 5 squared is 25. And 5 cubed is 125. Boom, that's what we were after. So instead of writing 125, we could write 5 cubed. So you could probably take it from here. So instead of 125, that's 5 cubed. And now the bases are exactly the same. So we could say the indices must equal one another. So 2x take 1 equals to 3. And let's make x the subject. So we get 2x equals 3 plus 1, which is 4. And then you're going to divide both sides by 2. And so x equals to 2 in that case. Beautiful. So they were nice and fun. Hopefully you were able to do these without a calculator. and you enjoyed yourself and you learned a bit. Thank you for watching, and make sure you leave a comment or hit subscribe. I'll see you next time. Bye-bye.